Parallel lines provide a direct structural shortcut in coordinate geometry. Because they never intersect, their slopes are identical, and their rise over run ratios are perfectly matched. The SAT often presents this relationship within standard form equations, like this setup. We have line J stacked right here above a parallel line K. The goal is to find the value of B, given that line K passes through the point 0B. A common approach is to rearrange both equations into slope-intercept form to find the slope. This requires multiple steps of isolation and division, which consumes time and increases the risk of making negative sign mistakes. Success on these problems depends on recognizing the structure hidden within the equations, rather than relying on brute force algebra. In standard form, the slope is determined by the ratio of the x coefficient to the y coefficient. For two lines to remain parallel, their x and y coefficients must scale by the exact same proportional multiplier to keep that ratio constant. By comparing the x coefficients, we can see the relationship immediately. 16 is exactly 4 times larger than 4. To keep the slope identical, we apply that same scale factor to the y coefficients. Since 5 times 4 is 20, our unknown coefficient r must be 20. It is important to ignore the constants on the right side of the equations when establishing this parallel relationship. Those values shift the line's position on the grid, but they have no effect on the slope. Identifying this geometric scale factor allows you to determine the unknown coefficient without needing to isolate y. Finding r is only the first step. Always reread the prompt before choosing an answer, as this specific question is asking for b, the y-intercept of line K. Because the point is at 0b, we simply substitute 0 into the x position and b into the y position of our updated equation. The first term cancels out, leaving us with 20b equals 15. After dividing both sides by 20, we find that b is 15/20ths, or 3/4. To practice this, look at these two new parallel lines. Pause the video and try to identify the structural multiplier first. Comparing the x coefficients shows a scale of 3. Applying that to the y coefficients, 4 times 3 tells us that p is 12. We can also use this logic when the unknown variable moves to the constant side of the equation. Here we need to find d, knowing line q passes through 0,5. First, we confirm the lines are parallel. Both the x and y coefficients have been multiplied by 4, so the slope remains the same. Since the parallel relationship is verified, we move to direct substitution. We plug the coordinates 0 and 5 into line q. The first term drops away, leaving 12 times 5. This shows that d is 60. To summarize these rules, remember that parallel lines in standard form always have proportional x and y coefficients. Rule 2. Always ignore the constants on the right side when you are solving for the slope multiplier. Rule 3. A point at 0b is an instruction to plug 0 into the x position. And finally, always reread the prompt to ensure you are solving for the correct variable. Using these geometric rules reduces the time spent on calculations and minimizes the chance of simple errors, preserving your mental energy for the rest of the exam.